In the last section, we got a very quick review of recursion. Let's now take some of these lessons right here and apply them to the steps problem at hand. So I've taken one of the diagrams we were looking at previously, and I pulled out some very interesting pieces of information. My goal here was to identify the base case, and I also wanted to identify the, remember, bare minimum pieces of information that represent our problem. So let's take a look at some of these different notes that I made right here. Okay, so the first big note right here is our base case. So if we imagine that we still have some row counter that we're going to pass during each recursion step, then if we increment row each time we kind of progress down here, whenever row is equal to n, and remember n was deciding how many steps we have in total, then that means that we have hit the end of our problem. So this was something that we noticed with our iterative solution as well. Remember, we had the for loop where we iterated from n up to, or excuse me, from 0 up to n. And as soon as we hit that, we said, okay, that's it, no more work for us to do. So essentially, I think that our base case here is to say, if we have some row piece of information that is being incremented from 0 to 1 to 2 and then eventually to 3, as soon as we hit 3, that means nothing else for us to do. Now, the next kind of interesting note that I made about our iterative solution here was I noticed that the stair string, remember the stair string kind of represented a row and all the elements within that row. If that row has a length of n, so row means length of n, or excuse me, a stair string has a length of n, it means that we are at the very end of the row and we are ready to print or to console log out that row. So if we have a string with 1 element, 2 element, 3 element inside of it, 3 is equal to n equals 3, that means that the stair string is ready to be printed. Now the last very important note here is that if the length of the stair string, so if the length of the string that is being used to generate, or excuse me, the string that is being used to represent the row here has a length that is equal to or less than the current row that we were working on, then we want to add in a pound. Otherwise, we want to put in a space. We saw this exact same thing just a moment ago when we were looking at our iterative solution. So remember, back over here, we had said that we had that inner for loop. We had the inner for loop that iterated through our list of columns. And if the column counter that we had inside there was less than or equal to the row counter, then we would use a pound sign. Otherwise, we would use a space. The interesting thing about this solution right here is that you can kind of very quickly tell that this for loop right here, it was made to iterate from 0 to n. But we actually have another piece of information inside of that iterative solution that mirrors or kind of encodes that exact same counter. The length of the stair string right here, the length of it was always equal to the current column that we were iterating over. So back here, we were looking at the column counter to decide whether or not we wanted to use a pound or a space. But for our recursive solution, we're going to instead look at the stair string to decide whether or not we want a pound or a space. Whew, okay. So these are the 3 big things that are going to help us put together our recursive solution. So we're now going to flip back over to our code editor and we're going to put this thing together. Now, as we write the code for this, we're going to kind of speed through the implementation because honestly, writing out recursive stuff is challenging to explain, to say the least. So it's more important that you understand these kind of base cases right here and that you get a sense of how to kind of discover these on your own. Once you can think of your base case, life gets a lot easier and you can start to put together this implementation. So anyways, let's just put this thing together and see what it looks like. So back inside my code editor, I'm going to take my whole steps function, I'm going to copy it, I'm going to put it down at the bottom of the file and comment it out. Again, just so I have a nice little backup. I'll then scroll back up. I'm going to clean out the steps function, so it's now empty. All right, so the first thing we're going to do here is we're going to define our base case, and we're going to check to see if the base case is satisfied, and if it is, we will return. So I'm going to check to see if n is equal to row. And if it is, I'm going to immediately return. Now, right away, you'll notice that there's no variable inside of here called row. So let's say that every single time that we call the steps function, one very important piece of information that we always want to pass along to every function call of steps is the current row that we are operating on. So as an argument to the steps function, I'm going to add in row. Now the first time that steps gets called, we can assume that it'll be called like this, steps of 3. Remember, that is exactly what the directions up here said. It said write a function that accepts a positive number n. So I'm kind of arbitrarily deciding that there is an additional argument that I want to add into this function call. Now, just like we saw a moment ago over in the code editor over here, we need to make sure that if row is for some reason not defined in our function call, we need to give it some default argument. Otherwise, we might get some really unexpected behavior. So to handle the first time that steps is called, where presumably row will not be passed along, I'm going to default the value of row to be 0. So this means right here, I want to start on the very first row, or the top row of our problem. Okay, the next thing that we're going to do is we're going to examine our second case, the second important note here, this one right here. We're going to write in some code that checks to see if the length of the stare string is equal to a length n, or excuse me, equal to the variable n. If it is, then that means that we are at the end of the row, and we should probably print out the stare string. So the next thing we'll do, back over here, we're going to check to see if n is equal to stare.length. And if it is, then we need to assume that we are at the end of this particular row, and we should print out the stare variable. Now again, you will notice that we have not yet defined stare. So stare is another piece of information that I really think that we need to share in between function calls. So as an additional argument, I will assume that we're going to call this thing with a stare argument, and I'm going to give it an initial default value of an empty string. So by default, nothing is inside of stare. Now the only thing that we have to take care of now is figuring out how exactly we are going to decide to call steps again in the future, and how we are going to make changes to stare and row. So at some point in time, we need to increment row right here, and at some point in time, we need to add a character onto stare. I'm going to ask you a question here. When do you think we need to increment row? Row needs to be incremented when we hit the end of a row, like when we have completed a stare. And we just wrote an if statement for that right here. So whenever we have hit the end of a row, we're going to console log out stare, and then we're going to call steps again, but this time around we're going to increment the value of row. So after we hit the end of the stare, we'll console log stare, and then we'll call steps, still with n, but with row plus 1. Now you'll notice that I'm not going to provide a third argument here, because when we move on to the next row, I want to use an empty stare again. And so I'm going to rely upon the fact that we are using a default stare value of empty string here. I could very much just as well do something like this. I could pass an empty string manually, but it's not necessarily necessary because we've already got this default value set up here. Now the other thing to keep in mind is that if we hit the end of the row, as indicated by this if statement, and we console log this thing, and we call steps again, we don't want to do anything else inside this function. So if we meet this case right here, there's nothing else we want to do. So when I call steps right here, I'm going to make sure that I just return right away. Now we don't necessarily have to return the value of steps. That's not necessary. If we wanted to, we could put return down on the next statement because we are not returning anything here per se. I just want to point that out. Not really important either way, just one thing to keep in mind. Okay, so we've handled the case that we have completed all of our work. We've handled the case where we've hit the end of a row. The last thing we have to do is handle the case in which we are still assembling our stare string. And remember, the big thing to keep in mind for that was that if the length of the stare string is less than or equal to the row that we are currently working on, we're going to add a pound. Otherwise, we're going to add a space. So for that, we can add in a little if statement. We'll say if stare.length is less than or equal to row, then we want to add a pound onto stare. So we can say stare plus equals pound. Otherwise, we want to add a space, like so. Now the very last thing to keep in mind here, the last line of code we need to write, notice how the only point in time right now that we do any type of recursion is if we've hit the end of a row. But we still need to make sure that we recurse through a row as well. So after we have appended on some character to the stair string, we then need to call steps again. And that's going to start the entire process over again. So after we do that if statement, we will again call steps. We'll pass in n. We'll pass in row. And notice that we are not going to change the value of row here because we are still working on the same row. And then the last thing we'll do is pass in stair. Okay, so I know this has been a little bit complicated, but I think that if you really think through these steps, they make a lot of sense. The problem with recursion is that arriving at which steps to put together is really challenging. You know, this is the kind of thing where when you see the solution, you can go like, oh, that makes sense. But before you see it, it's the hardest thing in the world. And that's why recursion is kind of notoriously difficult to pick up. All right, let's do one last run through here. So the first time we call steps, and I'm going to remove steps 3 up here, by the way. Make sure you get rid of that. Don't want to throw off any tests. So make sure you dump that statement. So the first time we call steps, we're going to have n of like 1, 2, 3, 4, 5, whatever it might be. We'll have a row of 0, and we'll have a stair of empty string. So n is 0, 0, empty string. Is n equal to row? No, it's not, because n is equal to 1, 2, or 3, or whatever. Is n equal to stair.length? No, it's not, because stair is still an empty string. Okay, well then let's go down here. Is stair.length less than row? Well, stair.length is 0. Row is equal to 0. So yes, it is equal to or less than. So we're going to add a pound to stair. We then call steps again. So we go back up to the top. Again, we have n of 1, 2, or 3, whatever it is. We have a row of still 0, but now stair is a pound. This case doesn't apply. This case doesn't apply. We hit here again. Stair now has a length of 1. 1 is not less than or equal to row. So we fall into this case here. We add on a space to stair, and then we call steps again. So at this point in time, stair is now equal to pound space. Row is still equal to 0, and n is still equal to 1, 2, or 3, or whatever. So this no longer, not relevant, not relevant. We hit here again. Stair.length will be 2. So we fall into adding a space again. We call steps again. We now add on an additional space, and now this is the last step we'll go through right now. We call steps again. We have, let's say, 3 in this case. Row is still 0. Stair is now pound space space. We check to see if n is equal to row. No, it's not. We check to see if n, which is 3, is equal to stair.length, which is 3. Yes, it is. Okay, so we console log out stair. We then return from this function, so we do no other work inside of here. We call steps again, but this time steps now have steps of n equal to 3, and row is now moved on to 1. The entire process repeats until we hit this case again, and then eventually row is incremented up to 3. We check to see if n is equal to 3. It is, and so we return. Whew. All right, so that's the full run through. Yeah, recursion is real nasty. Like I said earlier, my big tip to you in an interview setting, if you get asked anything about recursion, try to put together the iterative solution first, and then look to refactor it over to recursion. It will make your life easier. And in fact, when I put together this recursive step solution right here, that's exactly what I did. I put together this iterative solution. I looked at which variables inside of here were changing, and then I realized, oh, okay, like we can probably do it, X, Y, Z, and identified that base case, and it made life a lot easier. If you asked me to put together this recursive solution from the get-go, yeah, I would have a tough time, probably like most other people in the world. So I really recommend, if possible, you try the iterative solution first, just to get your mind in the right place, and then go to the recursive solution. Now, the last thing I want to mention here, completely optional, but if you wanted to, we could definitely shorten up this if statement down here with a little bit of a ternary expression. So this is totally optional. This is 100% equivalent syntax, but it'll just kind of condense down our solution. We could say something like const add equals stair.length less than or equals to row. And then if this expression right here is true, we would assign a pound to add. Otherwise, we would assign an empty string to add. And then when we call steps, we would pass in stare plus add. So in this case, add is short for like character to add. Okay, so I think that's the only refactor that I kind of want to do here to shorten things up. And of course, I bet we could maybe shorten up one or two things here beyond this, but I'll leave that up to you. Okay, so that's pretty much it. That is our recursive solution. We will look at recursion again in this course several times. Again, I can't say enough. It's one of those things where you just have to see it many, many times before you start to get a feeling for it yourself. Now, I did forget to do one thing. I'm going to check my tests. Yeah, they're still passing, so we're all good there. Okay, so I think that's enough on recursion. Let's take a break and continue on to our next problem in the next section.